So I am live now. Let me check this. Okay. I am live. So today I'll be doing Div 2 round 722 Div 2. Let's see how it goes. Shark has an array of consistent and integer. A shark can perform the following operation any number of times. Choose some subsequence of A and delete every element from it which is strictly larger than AVG. Where AVG is the average number of in the choosing subsequence. Okay. So Langul if A is 1, 4, 3 to 4 and Ishaq applies the operation to subsequence containing to A2, then you will delete those 4 elements which are larger than. So after the operation there is 1 to 2. Okay. Your task is find the maximum number of elements Ishaq can delete from the array by applying the coordinate division 0 times. So we need to find maximum number of elements to be deleted. Okay. So first, okay. First base continues subsequent B subsequent array C B of the function might be several. Okay. I know. So 1 1 1 2 2 3. So in this case we'll have this subsequent all the numbers and we will just delete 3 2 and 2 and we'll have 1 1 1. We can't delete 1 3 9 9 9 0 6 4 1 1 4 1. Okay, so in this we will just delete 4 and we'll see 3. So I just take the input and answer is equal to 0. Let's just sort the input. Now the answer should be all the values except the first line, right? So I'll just go through the current element to A0 while current element no. What if all the elements are same? Then answer should be 0. Okay. If A of I is greater than current element, then break. So first, if there are 3 elements, 1, 2, 3, then I'll just remove 2 and 3. So I is 1 and 3 minus 1 is 2. Right? So I need to print and delete. Okay. Yeah. Continuing break. And I'll just define this outside. Just let me P06 to the answer. P06. I hope I'm not missing any test case. Problem B. Sequence B1, B2, B is called strange if the absolute difference between any pair of its elements is greater than or equal to maximum element in the sequence. If the absolute difference between any pair of elements is equal to the maximum element in the sequence. Okay. Formally speaking, it's strange if we have AI minus AG with max is equal to in particular as more first stage. Okay. For example, sequence this and are strange, but please not strange because this is maximum element is -1, maximum element from difference is -1, difference is 0. Zero is greater than two. Okay. So has an array of integers, if it likes everything big, so among all states subsequence, the way you want to find the length of the longest one can help him. Okay. Frequency is something whatever. Okay. So we have 10 integers and among the all the states, the strain subsequence, we have to find the length of longest subsequence. Okay. So -1, -2, 0, 0. In this case, the longest subsequence would be max is 0. So longest subsequence would be 4 because -1 and -2 is greater than 0. -2 -0 is greater than 0. 0 minus 0 is greater than equal to 0. And -1 -0 is also greater than equal. So when would be the answer would be less? When okay. So in this I can do one thing is just to remove the positive element 4 and 6 and 1. So if I take max as this element, then minus this is true. Okay. And every element is true. Like if I take max as 1, then let me just solve the array first. If I take 1 as the maximum, then this fine. Everything is fine. So I just move to 4 and 6. So the answer it should be 5, right? So how I have a brute force approach in mind, but T stands for 4, and so I can do only n Roman. 3, 1. Maximum that is 2, 2 minus 1 is 1. Not 2. Just move 3, 1 and 2, then 2 minus 1 is 1. So, so 0 is answer. Okay, so single or. So I just need to remove the zero, like after positive elements after zero. So how do I know that maximum difference? Difference of number basis? So so I just brute force from this to this, and if I found that difference of number, current difference is greater than the element, then I just break it here. Sorted. So I know that int answer equal to 0 and current difference is equal to, let us say, no, a of 0. What if there is a single element, what is the range of m? So if n is equal to 1, then I just bring down. If there is a negative number, then it is also a positive. Current diff quantity, current diff equal to a of 0 minus a. Okay. So I'll just go through the array. If a, first I'll do is what difference, right? So a of I minus a of I minus 1. Absolute value. Okay, so why I'm thinking because right, it's greater than Cardiff, and Cardiff is a of I. No, I need to find the minimum difference, right? So that it will match. Okay, so it would be less. Okay, okay. Now if a of I is less than Cardiff, break, and I defined I outside. It's kind of similar to the last one. Okay, see out. What is the need to output is longest. Hmm, so I need to output I minus 1, because if this goes this condition holds, then I will not be taking that element. And then, so what if there is no conditional, for example, I'll take 2, 3, 1 then. 1, 2, 3, it is sorted 1, 2, 3, difference is 1, and I'll check 1 is greater than 1, then no, it will go again. Then 1 is greater, then it will just break, right? Just this 4, 5, 4, 1, 3, 4. Oh my God. What I have done. The philosophy is less than Cardiff. Let me just print what is the Cardiff and everything. Oh, oh, and also I will. So -2, -1, 0, and 0. Cardiff is 1, which is right. A of I is -1. A of I is -1. So correct. Cardiff is 1. That is also correct. A of I is -1, correct. If A of minus is less than. No, no. I think I have done something weird. If A of I is greater than car difference, no, then break. 3, 4, 3, 2, 3. 3, 4, 3, 2, 3. So I guess I still need this. 4, 5, 4, 1, 3, 4 is the answer. 4, 5, 4, 1, 3, 4 is the answer. Correct. Question. Break. 3 questions. Let me just check the standings. Really? I thought this is different. Okay. Parsa humongous tree. Parsa is a humongous tree on n vertices. Okay. On each vertex, he has written two integer LV and RV to make parser tree look even more majestic. Nima wants to assign a number to each vertex tree such that beauty of parser tree is maximized. Okay. Nima says the beauty is rather bizarre. He defines the beauty of tree as a column of AU minus AV or all the edges of the tree This parser tree is too large, Nima can't maximize it quickly on its own. Your task is find the maximum possible beauty of parser tree. So kind of weak at doing graph problem. So I have no idea how to do this. Okay, what is AU and first line T contain integer 2 and I and contains the LI and RI. Show the next MI line contain two integer U and V, meaning that there is an edge between our traces U and V in a parser. Okay, it is related that the given graph is a tree. The calculation of n voltage to find the maximum possible beauty of graph. So in first case we have 2 n is 2, so we have two vertices at 1 6 1 connected to 6. 1 is 1 and 6 for first and 3 and 8 for second, and then U and V meaning that there are differences, and 1 and 2 there is an edge. Okay, so let me just draw this so that I can understand it better. So what is saying we have 1 and 2 is coming, and for 1 we have 1 and 6 together. So 1 comma 6 2 comma 8. Okay, so we need to just take any value between 1 and 6 and 3 and 8, and what we need is maximum value of AU minus AU. So maximum value of this would be 8 minus 1, 7, right? Easy. Okay, so what if we have 3 vertices and suppose it is 4 comma 7, right? I think it is easy. I have doubt just if there are more vertices then it will be really difficult. So maximum value here could be 7 minus 1 is 6 and 6 minus 4 is 2. So 6, if I take this as 1, and the maximum value here is 8 minus 1, that is 7. So overall maximum is 7, right? Sum of, okay, so we need to sum, okay, so answer here is 13. If this question would be something like that, find the just maximum value, then I could just easily done this simple brute force approach. Find the maximum element here and minimum element here, and the opposite one also. Find maximum here and minimum here, and just take the difference. Okay. 3, 1, 3, 4, 6, 7, 9, 1, 2, 2, 3. So this graph is something like that I made, right? 1, 2, 2, 3. So 1, 3, 4, 6, 7. So here the maximum distance would be 6 minus 1. That is, one thing is sure that, okay, if I take 6, 7, 9, 9 minus 6 is 8, after 8. But if I take 4 here, the answer is 4 minus 1 is 3, and 9 minus 4 is 5, then also 8. So answer will be, so this test is, hmm. So just we will take the minimum element 3 here because this is an edge, and here we will take just 2. So here we will take 17, and 17 minus 2 is 12, is 5, 15 is 20, 20, and 19 minus 12 is 7, 27, 7 and 7, 34, 34 minus 7, 40, but it is not the right. There's no idea how to do. Problem B would be more tougher than this one. So we has 2 and point 9 on the OS axis. Sorry, oh, sorry, and one is division consider A and B the same consider the 4 and B is given. kind of. Okay, let me just. What if I take this? Okay, there are n nodes, right? And vertices. What I'm thinking is just brute force over all the values of n, and suppose this is the value I've taken as a maximum node, then I'll just take 10 as this value, and the remaining values I'll just take the minimum of these 10 minus 3, 20 minus 3, and 12 minus 3. And 50, and we have 2. So we have 2 power n. Let me just write the differences here. And I guess this is also not sure that we have to choose 17 and 13. I can choose any value between 17 and 13. So it's made it more difficult. Can I just assign this as A1, B1, A2, B2? Okay. So let me just assume that I took X, X1, X2, and X3 value of for each of them. Now what I need to is maximize X2 minus X1 plus X4 minus X3 plus X3 minus X2 to maximize this. So when this will maximum, so we have X1, X2, and X2, X4, and X3, and X1, X2, and X2. So I need to minimize X2 and maximize X2. Okay, sorry. So I don't know, no? Because this is a mode. So it can be X1 minus X2 as well. So this is or let's just take it like yeah. Let me just check the tag versus graph plus DP. I think I can do this. If I take DP, for example, if I just choose either 14 or 3, yeah, let me just leave this problem. Was a bad contest. I think I should study more concept of these and DP. Then I'll try these problems. Okay, so let me just explain the problem. Problem A was quite simple one. So it says we need to just remove the elements which are greater than the mean of remaining elements. So I can easily prove this as just uh, it doesn't depend how many steps I can take. I can remove every element except the last one or the last, last mean because we didn't have the any element greater than this. So what I have done is just took the input, sort the input. So for example, if input is something like 641141, 641141, then I just done 1114. So how this is answer is first we will remove 6 and 4 and 4 because sum is greater than 1, right? And now we have 3 elements remaining. Now mean is also 1, so we can't remove any of them. So our answer should be going from the first, check how many elements are same. So answer should be this. So I just sorted and current element is my first element, which is 1. I just brute force from 1 to n. If my element is greater than current element, then I just break and output n minus I. So in this case, I is 2 and output is 6 minus 2, that is 4. So I, no, I is 3, oh, sorry, because A minus A is greater than I. So it is just greater at I is equal to 3. So my output is n minus I, that is 4 minus 3. Sorry, 6 minus 3 is 3. Okay. So problem B. Problem B was also kind of similar to problem A. So I just need to find that when the difference is greater than the max, then I just need to break it. So for example, this is kind of, I'll take this 6 5 minus 3 2 minus 5. So 6 5 minus 3 minus 2 minus 5. So what I have done is first sort this so that all the maximum elements remains at the end. So minus 5 minus 2 minus 3 minus 2 5 and 6. So what now I have, the advantage is that all the elements greater than 0 are at the last. So our answer should be at least these elements, right? Because take a difference, so minimum difference would be 1. So 1 is greater than 0. So answer should be at least these elements. So what I have done is now brute force from this to this, from starting to end, and just take the what is the minimum difference here. Okay, so for example, in this case, minimum difference is 1 here. So if I found any element greater than 1, then I just break it here. So in this case, answer is 3. I just break this here. Okay, yeah, 3. 0 is also here, so I forgot to 0. So answer is 4, right? So let me just explain this. So I just took the input, sort it, answer is 0. If n is 1, if there is a single element in an array, suppose there's a single element, just return it, because in the next step I have taken the a of 0 minus a of 1, so that if there is a single element, then I am not exceeding any memory. So I took the current difference as first difference, that is 5 minus 3, that is minus 2, and absolute is 2. So current difference is 2, and for I 1 to n, I just took the now if the difference is less than the current difference, then the current difference is that difference, and this is just to output. And if a of I is greater than current difference, I just break it there and output I. It was kind of similar to the first one. And problem C is kind of difficult. I guess I need to do this by a DP, because one thing is sure that we need to take either the 3 or 14, because if if any element is greater than, if I take 14, if I take any element in the middle of them, and I can just decrease the element so that my answer would be maximum. Okay. Yeah, this was it, I guess. I will be doing more virtual contest. So